Hi. So in the last video I have shown you that how to draw the graph in physics. If you're given with the equation, then how can you draw the graphs? Today in this video I'm going to discuss about some application of the graph in physics. The most important application that we have observed in the beginning of the physics in class 9 and 11, that is the application of graph in kinematics. Kinematics is a part of the physics where we will discuss about the types of motion. Okay, like uniform accelerated motion, non-uniformly accelerated motion, uniform motion, non-uniform motion. So this kind of different kinds of motions we will enclose in the discussion of kinematics. Not the reason, only the type of the motion we discuss under the section of kinematics. Now today I will show you how we can apply the graph in the kinematics of physics and what are the application, what are the physical quantities that can be calculated from the graph. Okay, now in this physics kinematics, we are not only given with the equation every time to draw the graph, sometimes it will be given with the conditions, statements to draw the graph. Okay, so I will discuss all different kinds of graph which you will find helpful in kinematics. Mostly whenever we are talking about the motion of a particle, we need to understand few parameters such as displacement, velocity, acceleration. Okay, we also have distance, we also have the speed, but mostly we deal with the vector quantities such as displacement, velocity and acceleration, and we represent the motions in graph with these vector quantities. So I will restrict my discussion under the vector quantities of related to the kinematics such as displacement, velocity and acceleration with time of a particle. So I will start with the basic equations, how we can represent those equations from the previous understanding of the graph, and then I will come up with the statement based problems, and there we will discuss about how we can draw the graph from understanding the statement. Okay, so let's start with it. The first equation of the kinematics of a uniformly accelerated motion, we have v equals to u plus at. Now here you need to understand v is the velocity, u is initial velocity, a is your acceleration, t is your time. We are going to plot the graph for v versus t, velocity versus time graph. From the previous understanding of the graph, we know that y is equals to mx plus c. If m is positive and c is also positive, the graph will looks like this. But here the time is representing x-axis, so negative time cannot be possible. So we will start drawing our graph from t is equals to 0. So let's draw this equation over here. U is the initial velocity. So if initial velocity is positive, then it will start from some positive value of u over here. And the slope of this graph will represent the acceleration. So the findings from this graph is important. One, from a graph basically we can calculate two parameters. One is slope, another one is area under the curve. These two things we can calculate from a graph. Now we need to understand which physical quantity is represented in terms of slope and which physical quantity is represented in terms of area. So here we have the slope for this particular equation. You could understand from velocity time graph, slope is equals to acceleration a, and number 2, area is equals to displacement. Area is equals to your displacement. So this is your VT graph. Now we will further discuss about based with numericals that how we can calculate that. Okay. So I will give you a graph, and from the graph I will calculate the slope as well as the area to calculate the physical quantities of acceleration and displacement. Let's take an example of it. Vt for a particle is given. This is 0, this is 5, this is 10, this is 15, and this is your 10. Let's take it as 30. Okay, so the times are given. Time is given in terms of second, and the velocity is given in terms of meter per second. From this particular graph, suppose someone asks you to calculate the acceleration in the region OA, AB and BC. OA, AB, BC accelerations. Accelerations in region OA, AB, BC. So I told you from the velocity time graph, the acceleration can be calculated from the slope of the graph. So we need to calculate the slope in the region OA, AB and BC, and that will give you the calculation for the acceleration. Okay, so to get the slope, the formula for the slope is equals to y2 minus y1 by x2 minus x1. For physics, it's much more easier. Y2 minus y1 is the perpendicular and x2 minus x1 is the base. So it is simply understood that this is your 10s meter per second. So y2 minus y1 is your 10 and this is your 5. So this is 5 meter per second square, that is 2 meter per second square. Done. The next region for AB. Now AB is parallel to time axis. AB is parallel to time axis. That means there is no height. So if velocity remains constant, as AB is parallel to time axis, its velocity remains constant. If velocity remains constant, no acceleration. So this is for OA. Then if I talk about AB region, no change in velocity. No change in velocity. So this is equals to 0. So acceleration is equals to 0. Let's talk about BC now. So you can see the graph is going down. That means there is a decrease in velocity, So rather we have an acceleration, here we have a retardation. So that is decrease in velocity means retardation. So to calculate the retardation in the part BC, retardation in part BC, retardation in part BC. So what is the height? Again this height will be similar to this. So this is your 10, and what is the base of this right angle triangle is 3. So retardation is nothing but 10 by 3 meter per second square, that is 3.33 meter per second square. So as is the retardation, if we are willing to represent in terms of acceleration, we will use additional negative sign. So hopefully this is clear how to calculate the acceleration from the slope of a given graph. If a graph is given to you, then how can you calculate the acceleration and retardation from a given graph? That is clear. Okay, now next we will calculate the displacement, total displacement. Okay, total displacement can be calculated in many different ways. One, we can calculate this triangle area, then rectangular area, then again another triangle area. Instead of that, this is a trapezium. So area of the trapezium, area of this trapezium will gives you the total displacement of the particle. So how to calculate the total displacement of the particle? total displacement will be equals to total displacement is equals to area under the graph, that is equals to area of trapezium half into sum of the parallel sides. The base is your 13 plus what is this much 10 5 means this width 10 minus 5 is your 5 into what is the height is your 10, so that is half into 18 into 10, that is 90 meter is your total displacement. 90 meter is the total displacement. So from a given graph of velocity time graph, we can calculate two things. One is acceleration, another one is your displacement. Acceleration is the slope of the graph in the different region, and the slope and the area under the curve gives you the displacement. Okay, so let's talk about a statement based problem, how to draw this graph from a given statement. I will write the statement in the bullet point like this way. So a car starts moving, from rest. So it starts from rest. Next, it continues with acceleration of 2 meter per second square for the first 10 seconds. Next, then for next 15 seconds it continues to move with uniform motion. Then it creates the retardation of 3 meter per second square or 2.5 meter per second square and comes to the rest. Draw the velocity time graph. So object starts from rest. So the graph of the velocity time graph will start from 0 0. This is v, this is t. This is v, this is t. It starts from 0 0. What the time sections are given? First one is given as 10. Further 15 means 10 plus 15 gives you 25. And comes to the rest with speed of with a retardation of 2.5 meter per second square. No time has been given in the problem. So the first for the first 10 seconds continue with the 2 meter per second square. I am segregating the time zone with the dotted line. So it is uniformly accelerated motion from the rest. So it will be a straight line, rising straight line. Then uniform motion is this. Then come to the rest. That is final velocity is 0. So it will be like this. Now we need to calculate this time, obviously. So as it moves with 2 meter per second square for 10 seconds, the velocity will be v is equals to u plus 80. U is your 0. So v is equals to 80. 2 into 10, that is 20 meter per second. That is 20 meter per second. So here we got the velocity as 20. So if the velocity is 20 meter per second, then get the retardation time that we know the final velocity is 0, that is 20 minus 2.5 t. So t is equals to 20 divided by 2.5, that is 8 seconds. So the final retarding time is your 8 seconds. So it is 25 plus further 8, that is 33 seconds. So this was the graph. Rising, uniformly accelerated, straight line, rising straight line, uniformly accelerated, uniform motion parallel to the time axis, retarding motion downward direction. Finally comes to the rest, so it will touch the t-axis. So this is the graph. From the graph you can calculate the area that will gives you the total displacement of the particle. Total displacement of the particle. I think from the previous problem you know how to get this area of a trapezium, sum of the parallel sides multiplied with the height. So I think for this particular statement you can create the velocity time graph. It is clearly understood. Okay, let's give a quick recap how I could draw this one. Uniformly accelerated 2 meters per second for 10 seconds. So for the first 10 seconds I brought a rising straight line. Then uniform motion, horizontal line, final retardation motion, and comes to the rest. So it will touch the t-axis, downward t-axis. It's simple like this. Let's move on to the next problem. Okay. If you feel that I'm going a little bit fast, then you can slow down your speed in the YouTube. You got the option for 0.5, 0.75 speed. Okay, according to you, you can slow it down, you can stop, you can write the statement. Okay, so I will continue with the speed. So if you feel, you can do this option, choose this option to stop and pause the video. Okay, so let's take the new type problem. Next one is an acceleration time graph. Acceleration time graph. AT graph. Okay, VT, I think it's clear. Now acceleration time graph is quite tricky. So if you are given with this kind of acceleration graph, suppose, plus 5, minus 5, 1, 2, 2.5, 1.5. So you could understand this is a acceleration time graph is given. Now from the acceleration time graph, what are the physical quantities that we can calculate? If we talk about the acceleration time graph, for area under the acceleration time graph, gives you the change in velocity. Change in velocity. And if we talk about the slope, a by t, that will gives you the rate of change of acceleration. If they are asking you in the problem statement, can find the rate of change of acceleration, then you can do that. Otherwise, mostly from the acceleration time graph, where important to calculate the area under the graph, that will give you the change in velocity, not the velocity. They will give you the change in velocity. Some initial velocity will be mentioned and they will ask you what is the final velocity. So in this particular problem, suppose the initial velocity u is given as 5 meters per second and asking you what is the velocity at the end of 2 seconds. At the end of 2 seconds, what is the velocity v? So we need to calculate the area under this graph. So which area we are looking for? We are looking for this area, this shaded region. Only this much we require to calculate, because they are asking you to calculate the velocity at the end of 2 seconds. At the end of 2 seconds. So we can segregate this first triangle, second triangle, and we can calculate the area. For the first triangle, this is your first triangle, this is your second triangle. Area of first triangle. Area of first triangle, half into base. Base is your 1.5, that is 3 by 2. Height is your 5. So that is 15 by 4 meter per second. Positive area. Now if you talk about the area of second triangle, half into base is your 0.5, that is half, and the height is your 5, that is minus 5 by 4 meter per second. So the net change is equals to 15 by 4 minus 5 by 4, that is 10 by 4, that is 10 by 4 meter per second, that is 2.5 meter per second, and that is positive. That is your positive. So the final velocity at the end of 2 seconds, v is equals to u plus delta v, that is 5 plus 2.5, that is 7.5 meter per second. 7.5 meter per second. So in this way, with the help of an acceleration time graph, you can calculate the change in velocity, and further we can calculate the final velocity at the end of any time. So I think you can easily understand if I ask you to calculate velocity at the end of 1.5 seconds. So you need only to calculate this triangle, that is 15 by 4, and that will be added with this 5 meter per second to get the final result at the end of 1.5 second. So let's talk about other equation of the straight line kinematics uniformly accelerated motion, and we will understand how does it will looks like. So as we know, the second equation is your s is equals to ut plus half at square. The second equation is your ut plus half at square. Here the s is the variable displacement power 1, t has a maximum power of 2. That definitely gives you an idea. It is not a straight line, it will be a parabolic nature, and the graph looks like this. Those two different values of t gives you a single value of y, x, that is your s. So here we could not have the negative time axis, so it will only be lies in the positive t region. So this is the graph for uniformly accelerated motion for ST graph. For the ST graph, we mostly, for uniformly accelerated motion, we don't have such problems to calculate the velocity or any other things from the graph. But the slope of ST graph gives you the velocity. Slope of ST graph will gives you the velocity. Okay, let's move on to the next equation, the third equation of the kinematics. Third equation of the kinematics, number 3, that is v squared is equals to u squared plus 2as. V squared equals to u squared plus 2as. Now if you have asked to calculate v square versus s graph, v square versus s graph. So v square itself a variable, not v. V square itself a variable, so it will be a straight line. So if we assume v squared is equals to y, the equation is y is equals to u square plus 2as. So y power 1 is power 1. So it will be a straight line. And u square is a positive intercept, so it will looks like this. From the slope of this graph, if you are given with v square versus s graph, from the slope of v square versus s, you will calculate 2a, twice of the a. So slope divided by 2 gives you the acceleration. V square versus s, that is velocity square versus displacement graph. The slope will somehow give you the acceleration. Okay? Next. In general, those who are in class 11, they may not be deal with the uniformly accelerated motion. They may deal with any other kind of motion. We know that acceleration is equals to dv dt. So in the chain rule, if we break it, that will be dv ds into ds dt. So a is equals to v dv ds, or a by v is equals to dv ds. So that means if we have a graph between velocity versus s, not v square versus s, what do we have? We have v versus s. And that v square versus s, if it is a straight line, then that slope will gives you the acceleration. That means straight line means it is a uniformly accelerated motion. That is another discussion we can draw from the previous graph. If the v square versus s graph is a straight line, so that will represent a uniformly accelerated motion. Slope is constant. If slope is not constant, that means it is not a uniformly accelerated graph. Okay, so here you can see it is a v versus s graph. So whatever be the graph, I don't know, maybe it is looks like this, or maybe it is a straight line. Whatever it is, may possible it is a straight line. What does the slope gives you? The slope of this graph gives you a by v, the ratio of the acceleration to the velocity of that point, ratio of the acceleration to the velocity. Okay, so this is the discussion we can draw from the velocity versus s of the displacement graph. Okay, so there are few discussions we have done from the direct discussion of the graph. Let's try out another statement based problem. It's very important. Suppose a ball is thrown vertically upward with a velocity u. Velocity u. Draw the velocity time graph. Draw v versus t graph. Velocity versus t. It's very easy. Observe. Now physics is something related to common sense. You need to think, you need to reconstruct the scenario in your mind, and then you need to identify the thing. Okay, so if you're throwing a ball in an upward direction, initially the velocity will decrease. As soon as it reaches the maximum point, the velocity will become 0, and then it comes down with a velocity, increasing velocity. So that means as long as it moves upward, its velocity decreases. Maximum height, its velocity becomes 0. Then it changes direction. That means velocity, if initially we are considering is positive, then the next one we should consider it negative. That means it continue with a straight line and it will come like this. Straight line. So it is your u and this is your minus u. If this is considered as t, this is your 2t. So this will be the graph. For a ball is thrown vertically upward direction. That's all. So what are the discussions we can draw from the kinematics graph? We have mainly two different types of graph: velocity time graph, acceleration time graph. From the velocity time graph, we can calculate the displacement of the body, acceleration of the body. Acceleration can be calculated by calculating the slope, and distance can be calculated, displacement can be calculated with the help of the area. And for the acceleration time graph, area under the graph gives you change in velocity. Now I will give you one more thing, that is a displacement time graph for a statement based problem. Let's see how well we can draw that from the understanding of the statement. A particle is moving in a straight line. For the first second, for the first 10 seconds, is moved with a uniform velocity through a distance of 100 meters. Then it changes direction and it moves back to a length of 30 meters. Draw the displacement time. So the particle first initially moves through a distance of 100 meters, then it changes direction and comes back to a distance of 30 meters. So you need to draw the displacement time graph. Uniform motion displacement time graph. So first 10 seconds is reached to a distance of 100 meters. Then it changes direction and going back through a distance of 30 meters. like this is your 70 meter. The time is not given, maybe suppose for further 6 seconds. So this time will be your 16 seconds. So this will be your displacement time. For the first one, they move through a distance of 100 meter in 10 seconds. So 10 seconds, 100 meter. Then it goes back through a distance of 30 meter in next further 6 seconds. So 10 plus 6 becomes 16 and goes down through a distance of 30 meter. So this is your displacement time graph. So these are the few graphs we have in our kinematics. I have tried to cover all the different types of graphs we have. Okay, obviously the more discussions we can draw. One more thing that is, this comes to my mind, is very important. If I talk about the velocity time graph, this is a previous discussion, previous problem, what we have observed. If you found somewhere, this is a velocity time graph, arbitrary velocity time graph, this is T1. So at T1 you can see the velocity of the particle finally comes to the 0, and then it crosses the time axis and goes to the negative velocity direction, negative velocity axis. So it goes below the time axis. So at t is equals to t1 time, the particle changes direction. The number of time for the velocity time graph intersects the time axis, that will be the number of times it changes direction of motion. So here only one time it has intersected the time axis, that will only one time it has changed its direction. So that is initially it was positive, so next one it will be negative, considered to be as negative. So these are the all different kinds that we can sum up under the section of the kinematics graphs. We have discussed the velocity time graph, we have discussed the acceleration time graph, and I told you it will be related to the previous video where we have given you the idea of the general graphs. Okay, the general concept for the uniformly accelerated motion, the graph will be this type. This is your uniformly accelerated motion. Uniformly accelerated motion. This region when the velocity is decreasing, uniformly returning motion. This portion is parallel to time axis. Means is in this portion velocity is not changing. Means object is in uniform motion. So this is needed to be understood very carefully. Whenever you have an uniformly accelerated straight line rising, uniformly retarded straight line decreasing, parallel to the time axis gives you uniform motion. So these things you need to understand whenever you have to draw or you need to identify the nature of the motion. You need to match these things. You need to keep these things in your mind, and you need to identify which region is matching with another one, and that will be the final result. So uniformly accelerated, retarded, uniform motion, again it is accelerated. Okay, so this could be the end of the discussion of the kinematics. If further any other graphical problems you have, you can put it in the comments or you can put the mail in the mailbox. I will definitely try to make a video to solve those kind of problems for you. Okay, thank you.